Hi everybody. We are going to do some more reactions and examples of balancing chemical equations. I have 6 examples that are set up for you, and on these 6 examples you need to have your notebooks out and you need to be writing these out so that way you have these as examples in your notes. I'd like to look at this first one here, so let's look at this one. I have sulfur is reacting with oxygen to produce sulfur trioxide. So in this case, I left the dashes, the lines, because we're going to be using coefficients to balance an equation. And remember that we can't create or destroy matter, so I need to have the same amount of elements on both sides of the arrow. So if I look at my reactant side, let's just start off with sulfur. On the reactant side, I see that I have 8 sulfur atoms here. But if I look over on my product side, I only have 1 sulfur atom. So if I have 8 here and I only have 1 here, I need to add a number in front so that way I can make that 1 sulfur equal to 8 sulfurs. So what number am I going to write there? I'm going to write an 8. So now if I check again, I have 8 sulfurs on this side, and I have 8 sulfurs on this side. So sulfur is balanced now. Well, now I need to check my oxygens. I only have 2 on this side, but if I'm looking on this side, I have 3 oxygens, but that's times an 8 because I added that for sulfur. So I have 8 times 3, so that's 24. So I have 24 oxygens on this side. I need 24 oxygens on this side. Well, I already have this O2. So whatever number goes here, and if I times it by 2, I'm going to get 24. So what number should I write here to get 24 oxygens? I should be saying 12. So now I have a balanced chemical reaction. I have 8 sulfurs here, 8 sulfurs here, 24 oxygens here, 24 oxygens here. So that one's balanced now. Let's move on to the second one here. I have zinc plus hydrogen chloride, or we could call that hydrochloric acid. Those two are going to react to produce zinc 2 chloride and hydrogen. So first of all, let's just check. Let's check our zincs. I have 1 zinc on the reactant side. I have how many on the product side? Only 1. So zincs are balanced right now. I don't have to do anything to those. I have 1 hydrogen on the reactant side. How many hydrogens do I have on the product side? I have 2. I only have 1 on this side though, so what number should go here to have 2 hydrogens? 2. So now I have 2 hydrogens, 2 hydrogens. Still 1 zinc, still 1 zinc on this side. The only element that I haven't balanced yet is chlorine, so let's check it. I have 2 chlorines here on the product side. How many do I have on the reactant side? I have 2. Because I added that 2 as a coefficient, that 2 goes to the H, and it goes to the Cl. So I have 2 chlorines, 2 chlorines, 2 hydrogens, 2 hydrogens, 1 zinc, 1 zinc. So this one is nice and balanced for us now as well. Okay, let's move on to the third example. I have potassium oxide plus water makes potassium hydroxide. So I have 2 potassiums on my reactant side, but I only have 1 over here on the product side. So what number should I write in front of potassium hydroxide to make sure that I have 2 potassiums? We should add a 2 here. So now I have 2 potassiums here, I have 2 potassiums here. Let's look at hydrogens next. I have 2 hydrogens on my reactant side. I have 2 hydrogens on my product side, so those are balanced. Now let's also check the total number of oxygen that I have. I have 1 oxygen here and another one here. So the total amount of oxygen on the reactant side is 2. I have 2 oxygen, 1 here, 1 here. Let's check on the product side. Since I wrote my coefficient 2 here, I have 2 oxygen. So this one now is good and balanced. Okay, what happens if the numbers get larger? So let's try example number 4. And actually, I'm going to erase this little number 4 here just for some more room. Okay, I have how many carbon on the reactant side? I have 7. 7 carbon on this side. But how many do I have on the product side? I only have 1. So I have 7 on this side and only 1 on this side. So what number am I going to have to add here to get 7? If I have 1. 7. So now I have 7 carbon here, 7 carbon on this side. Now let's look at our hydrogens. So I have 16 hydrogens on this side, but if I look on my product side, I only have 2 hydrogens on this side. So I have 16 here, but I only have 2 on this side. So I'm going to have to multiply that hydrogen by 2, where I'm going to get 16. So something times 2 is going to give me 16. So that's going to be 8. So now let's check again. 7 carbons, 7 carbons, 16 hydrogens, 16 hydrogens. So carbon and hydrogen is good. Now I need to check my oxygen. Well, I've already balanced everything over here, so I think. So let's check how many oxygen we have total on this side. I have 7 times 2 oxygen here, so 7 times 2, that gives me 14 oxygens here, plus another 8 oxygen. So I have 14 oxygen plus another 8 oxygen. So total on this side I have 22 oxygen atoms. Well, I only have 2 right here. So whatever number I have here multiplied by 2 needs to equal 22. So something times 2 has to be 22. What number am I going to write here then? 11. So that's more, I think, of a difficult problem just because the numbers or the coefficients are a little bit larger. So what happens now if we have a reaction that has polyatomic ions in them? Because you're going to see a few of those. And there's a little trick that I want to teach you that's going to help you balance them faster and easier. So I have here iron 3 sulfate. So I have Fe2SO43. And that's reacting with potassium hydroxide, KOH. And I'm producing potassium sulfate, K2SO4, and iron 3 hydroxide, FeOH3. So if I'm looking at my reaction, there's a lot of elements that are in here. If you have polyatomics that you see exactly the same on both sides, I see I have a sulfate, SO4 on this side. I also have an SO4 on this side. Don't break those down into their elements. Think about them as a unit. So if I'm looking at these, I have 3 SO4s on this side, right? Because that SO4 is in parentheses, and I have that 3 on the outside, so that means I have 3 of them. So I have 3 SO4s. If I go over to my product side, I look over here, how many SO4s do I have on this side? I only have 1 SO4 on this side, but on this side I have 3. So if I have 3 on this side and only 1 on this side, I need this side to have 3. So what number can I write in front of K2SO4 to get 3 sulfates? I'm going to write a 3. Okay, so now that means I have 3 sulfates here, I have 3 sulfates there, so my SO4s are good. Now let's look at, since we added this 3 here, let's just look at potassium. So potassium, I already have a 2 next to that. So I also added this coefficient. So what's the total amount of potassium I have? I have 6. 6 potassium here, because I had this K2, but then I have to multiply that by 3. So I have 6 potassium on this side, but I only have 1 over here on this side. So what number should go in front of KOH? We should say 6. Because now I have 6 here, and I have 6 on this side. So potassiums are balanced, sulfate ions are balanced. I'm almost done. Let's look at iron, which is Fe. On the reactant side, how many iron do I have? I have 2. But if I look on my product side, I only have 1 iron. So if there's 2 over here and 1 over here, what number am I going to add to this one to get 2? going to add a 2. Okay, lastly, I just need to check my hydroxide ions. That's the only thing we didn't balance. So if I look on my reactant side, I have 6 OHs. If I look over here on my product side, I have 2 times 3 OHs, which would give me 6. So those are balanced as well. So we have a nice balanced chemical reaction. Now doing these with the polyatomic ions is trickier, but again, if you would use the ion as an entire unit, I promise you it will be so much easier. So think of those polyatomic ions as units, and like as a whole, don't try to break them up because it will just make things easier. Let's do another example with some polyatomics, okay? Just so that way we can like solidify this. I have aluminum sulfate, so I have Al2SO43, and that's reacting with calcium hydroxide, CaOH2, and that will produce aluminum hydroxide, AlOH3, and calcium sulfate, CaSO4. Okay, again, I see sulfates on this side, I see it as a unit here on this side. I see hydroxide as a polyatomic ion on this side. I also see it here on this side. So my goal is to try to balance out these polyatomics first. It's just easier to balance out these polyatomics. So if I have 3 SO4s on this side, I need to look over here. I only have 1 SO4 on this side. So to get 3, what number will I have to write in front? 3. Okay, so just check again. 3 SO4s, 3 SO4s. But now I need to look at calcium. Since I added this 3 here, the 3 doesn't just go for SO4, it also goes for calcium. So on the product side, how many calciums do I have? I have 3. But on the reactant side, I only have 1. So to balance out calcium, what number will I have to write here to get 3? 3. 3 calciums, 3 calciums. 3 SO4s, 3 SO4s. Okay, let's look at aluminums. I have 2 aluminum on this side, but I only have 1 aluminum on this side. What number will I write here? If I have 2 on this side and only 1 over here, I need to add a 2 there. So now I have 2 aluminums, 2 aluminums. 3 calciums, 3 calciums, 3 SO4s, 3 SO4s. The only thing, again, that's not balanced is hydroxide, or that I haven't checked yet. So if I look here, hydroxide has a little 2 next to it, so it means I had 2 hydroxides. Oh, but I added this 3, so that really means I have 6 hydroxides, because 2 times 3, I got 6. So I have 6 hydroxides on my reactant side. Now I need to make sure I have 6 on my product side. So I had 3 hydroxides originally, but I added a 2. So again, 2 times 3 gives me 6 hydroxides. We are balanced. We are good and balanced. Okay, for the rest of your class time, you will be working on a worksheet on balancing chemical equations. On that worksheet, there is a front and a back. You have 34 reactions that you are required to balance. The only thing I would like you to do, don't worry about like the lines that are randomly everywhere. I just want you to write in the little blanks that are provided for you in the reactions, the coefficients or the numbers, okay? Don't worry about the questions at the end on the other side where it says which equations are synthesis, which equations are decomposition. You don't have to worry about that right now. I just care about you balancing. Whatever you do not get done in class is homework, and I do not want to hear any excuses tomorrow or Friday whenever I come back that you don't understand this. We had class time today for you to ask questions, and there are 6 examples now that I just went through to give you more help on this. So whatever, again, you don't finish in class is due for homework, and it will be due on Friday. And I would not be surprised for a pop quiz on this on Friday. I'll see you tomorrow. Bye.